Hey, welcome to another episode of Toy Trains and Arduino. And no, this isn't yet another video about robot cars. But we will end up creating a robot car just to test our concepts out more fully. But the important thing here is I'm going to show you the details in how to control your projects using your phone and not having to write any Android app. And that can be really important, particularly if you're going to have several projects on your layout that you want independent control of, and you want immediate response, like you're throwing switches or stuff like that. So stay tuned if you want a quick, easy way to control your projects with your phone. We're going to briefly mention connecting to your phone using Wi-Fi, Bluetooth Classic, and then we'll spend the rest of this video talking about how you can use Bluetooth Smart and WebBLE to connect your phone the easy and quick way. You can use Wi-Fi to connect your MCU project to your phone. In that case, you might create a web server. Your ESP32 or other MCU connects to your local network through your access point. This has the side effect of potentially creating latency because of where the access point is located. Alternatively, you can set up your MCU project such that it acts as an access point, and that helps eliminate those latency issues. The good thing about Wi-Fi is it's a high throughput data. So if you're streaming video, this is probably what you want to use. The problem connecting your phone directly to your MCU project using Wi-Fi is you can only have one such connection at a time. So you'd have to close out of one in order to start the other one. And that may not work for you at all, or might be annoying if nothing else. Last year, we did a video on using Wi-Fi and making the ESP32 act as an access point for that project. If you're interested in that, check out my YouTube channel, subscribe, and check out last year's videos. Another good way to interface your phone with your MCU projects is to use Bluetooth Classic, or what people usually mean when they say Bluetooth. And that works really well. The downside is you're going to need to create an app to handle the user face elements on your phone, and that can be really hard. I don't know about the iPhone, but the Android Studio is full of way too many libraries and way too many versions of those libraries. And that makes it hard and confusing. And the upside is this can work with both iPhones and Androids. You just have to write the app for the phone. And the other good news is the data throughput is very good and the latency is low. I use this method on my layout for everything from controlling switches, reading current, reading train speed, reading and writing RFID tags. Finally, that brings us to Bluetooth Low Energy, sometimes called Bluetooth Smart. We're going to refer to it here as BLE or Bluetooth Low Energy. Like Bluetooth, there needs to be an app running on your phone for user interaction. But that app can be your web browser, and that's where WebBLE comes in. So we don't actually have to write our own app. We can use HTML, JavaScript, and CSS to create full-featured user interface connecting your phone to your ESP32 project. Only small bits of data are transferred at a time, 20 bytes. So that's very important. However, it can be very low latency, or at least low latency. One thing to note here is Bluetooth and BLE are very different. In Bluetooth, you interact with the app on the phone through a serial type connection, something you're probably familiar with. With BLE, you have this whole scheme for sending short messages. And we'll talk a little more about that in a minute. So you should not expect to just be able to port your Bluetooth projects to BLE. Okay, so what is WebBLE? WebBLE runs in a Chrome browser on Android. It does not run on iOS or iPhones and anything like that. It does not run in Chrome browsers on operating systems for the most part. I know it doesn't run on my Ubuntu, for example, but it does run on Android, which is what we care about if we want to interface our phone to our ESP32 project. And because it interfaces to the Chrome browser, or as part of the Chrome browser, then we can use JavaScript, HTML, and CSS to create almost any kind of user interface element we want. Debugging works and is pretty awesome. We can use our computer for debugging the app while it runs on our phone, which is pretty awesome. This does require a special security model. Therefore, it requires HTTPS. The way we arrange our BLE interface to our projects to run on HTTPS is to put the project on GitHub and then host it from GitHub. And everything you need to know about how to do that is at the GitHub site. Created a couple apps that use WebBLE to talk to two different ESP32s. One's a S3, one's a C3. This is the C3, and it's driving those motors in the car. You see the wheels turning, and that's a touch interface. I'm just using the pen so you can see where I'm touching. And then I'm just going to switch to the other app, which is just moving two servo motors. You can see that red moving in the background. And if I go on the other axis, we'll see the blue will move. There's also an LED, which you can see just sort of lighting up behind the green LED. It's red. And then, so here's us moving both servos at the same time. And we can then connect it to that. While still connected to that, we can go back to the servo car and move those wheels. And so there's an example of what we're after. Okay, I know what you're thinking. How can I get going with this quickly? Well, the best way is to go to the Random Tutorials website and go through step by step their getting started with WebBLE, and that'll get you up and running. What I'm going to talk about from here on will build on the example provided by Random Nerd Tutorials. Finally, we're going to come to the details, and we're going to go through some example code. In each case, this code has been run on the ESP32C3 or the S3. We're going to use WebBLE to both do control of LEDs, motors, as well as get status updates. A number of issues popped up as we went through creating these apps. So what I'm going to focus on is how I've enhanced or built upon the Random Nerd Tutorials example. Go through that example after watching this video, or if you want to stop now, go through the example and come back here. That's cool too. See my GitHub page for all the code we're going to talk about now, as well as the Random Nerd Tutorials WebBLE webpage. All right, so here's what we're going to do. We're going to expand on the example by going through some experiments. We can learn some things about what the example does, but then we, in the end, learn a lot about what we need to actually do a project. But first, we need to connect our phone to our computer so that we can see what's going on when we use our phone under the hood. So what we're doing here is connecting to the JavaScript debugger through our USB. And this way we can run our app on our phone, have our touch interface, and see everything that's going on our computer. And we'll show you how to do that right now. So what you're going to do is you're going to go to Settings, and then you're going to go down to About Phone. And if you've done this already, you can skip it, but you'll go to Software Information. And what we're going to do is we're going to tap on this build number a bunch of times, and then it'll tell us it's turn developer mode on. And so we need to have developer mode on, and then we go back to our settings and we go to the bottom and we now have developer options. Under developer options, we have USB debugging. We turn that on and say OK, and then allow. And now our phone is ready to go. The next thing we do is we load our web page. And we're now ready to connect it to the JavaScript debugger on our computer while we're connected through the USB cable. And on your computer, you bring up your web browser, and you're going to go to this page right here, and that should bring up a prompt on your phone that's asked if you allow USB debugging. You say allow that. Okay, and then there's this box here. If it's not checked, check it. Otherwise, if it is checked, uncheck it. And when you toggle that so that it's now unchecked, you're going to find that your web page title appears in this list down here. Servo Test Web BLE app. That's what we want. So when we click Inspect, we're going to get the full debugger and control over our phone. We can touch our phone and operate it this way so that the screen came on, or we could use our mouse and change the settings on our phone, toggle the red LED. We could even use the touchpad using our mouse, or we can use our finger. And that's the way that works. And we get messages, debug messages probably, right here. And this is incredibly useful for developing WebBLE apps. And today we'll use it to do a number of experiments. All right, for starters, we're going to look at touch events and see what those look like. And we can get a good idea what they look like by using our debugger. In the code, we're just going to add handlers for a touch start, a touch end, and touch move events to the dot class, which is visualized here as the big gray dot. So that's how we get our events. And then this is where we handle them. And we just want to first see, okay, what do those events look like? So I'm just going to uncomment that so that when we handler gets called, it prints whatever touch event it got and tells us about it. All right, so we just use this right there to do that. All right, we need to send that over. Okay, so we sent that over to our GitHub page. And so one thing that you'll notice, if we go there, we can look at the source. Here's our touch handler. Here's the line we just uncommented. You notice it's still commented out. That's because we need to reload this. And even after reloading, it's still commented out. That's because GitHub has to do some processing because it's tracking changes. It's just not going to replace the file. So it takes some time. And boom, now it's done. All right, so not a lot of time, but you're going to have to look to see that your change is actually on the page you're using before you test it. All right, so now let's test it. We'll just say go and come back here to the console and do some touching. Wow, so that was 6 moves if we look at look down here on this, on their screen, and we got 263 user messages. That's a lot of messages. And this is what they look like. We get this information, we get various x coordinates, we get some bounding information, angles. There's an image there, so it tells us all about that. So there's a lot to these events. The take home here is I made 6 moves. In other words, I wanted to move that motor, the 2 motors, a total of 6 times. And that generated 263 events. So if I'm sending all those events to the ESP32, I'm going to overwhelm the Bluetooth and possibly the ESP32. So I don't want to do that. So what I do in my code is I just check to be sure there's a reason to do the moves, right? So that's what all this is about. When I have a move, I want to be sure it's not the same as from the last position, and I want to be sure it's not the same as the last move I did before, so I don't send it again. I want to be sure this is actually saying, oh, this is a move that does nothing, so don't send that, right? So I want to, depending on what I'm doing, what my motors are doing, I want to think about ways I can just reduce the number of times I tell the ESP32 to move. So we have to get through all these if clauses before we actually will move the ESP32. What are CCCDs and why should we bother with them? This comes up in the Random Nerds tutorial example. We're going to take a closer look at the one they used and then examine another CCCD that most projects probably should use, although even that's in doubt. Now we're going to talk about Client Characteristic Configuration Descriptors, or CCCDs. What do they mean? In the Random Nerd Tutorials example, they used 2902. And 2902 basically enables the client to say what it wants in terms of notifications and indications. You notice for writes, these are not needed, and we tested that out, and yes, indeed, they're not needed at all. So that's the only time you really need it. The other thing we experimented with was the 2901, which allows us to create human-readable descriptions for all of our characteristics. So here we are creating one for the servo status, which is our notification that we use. And here's one we're creating for the control characteristic. That control characteristic is used, remember, to stop the motors immediately. And then here's one for toggling the LED on and off. And basically these just create text strings that clients can potentially read and show to the user, since it's human readable text, which is a nice thing to do, and we should probably be doing it. However, the thing I discovered by playing with it is that applications don't pay any attention to it. And in particular, WebBLE doesn't pay any attention to it. Next, we're going to do some experiments with something called min preference. And that is actually best thought of as a min interval preference. And we'll talk a little bit more about that. What does that really mean? You can think of this as like a clock. This is the interval with which the client and server are going to talk to each other. And they will do this even when there's no data to be sent back or forth. So it's a regular interval with which packets will be sent. Sometimes those are empty. And there's a minimum value to this interval, and it's different for different hardware. notice that what we care about, since we're using WebBLE and the only devices that support it are Android devices, we look here, the smallest interval that those devices can do is 7.5 milliseconds. Now also, during this interval, the client and server can send more than one packet. So they can send up to 6 packets. And again, Android we see are the devices that can send 6. So if you think about it, if each interval goes by, the more you send here, the higher throughput you're going to have. Or another way to look at it, the more intervals you can use, the more throughput you're going to have. So what we did is we did a bunch of experiments where we varied the min preference, or let's just call it the min interval because that's what it really is, and recorded the results. We tested from 7.5 milliseconds all the way up to greater than 1 second. And what we found was it made no difference whatsoever. And this probably makes sense because in the end, it's really going to be determined by the client. The client here is WebBLE, which is servicing JavaScript. And JavaScript is single-threaded, so it cannot be really held to a very tight standard, which means it doesn't matter what we put in here. We probably should just go ahead and send 0. 0 for the min preference, the min interval. That's just the server's way of saying, it's up to you, client. I'll do whatever you say. Now we're going to talk about the difference between write and R when it comes to the client telling the server to do something. All right, so you will find lots of WebBLE examples that look like this and look like this, where you're setting up the way, in this case, that the client can tell the server things. In this case, this is how one normally sees how to turn on an LED. But you have an option here, and you can simply say write under NR. And basically, there's a difference here, and that is when you use write, it writes, the client writes to the server. The server then is required to reply that it got it. When you use write NR, the server is not required to reply. And that reply is handled by the BLE layer. You don't do anything in your code when you're using the Arduino library for BLE. The Arduino library takes away your ability to do something with that response, even that there's something wrong and you weren't able to send the response due to a network error or some such thing. Using that response does have limited utility, especially in the case of notify. Now, notify doesn't require a response. So in this case, with notify, the server, your ESP32 is the server, it posts a value and then it's done. The alternative to notify is called indicate. Your server posts a value and then it wants to have a reply from the client for indicates. The BLE layer is making that response on your behalf. Does it go through? Was it successful? What was the answer? None of those questions can be answered when you're using the Arduino library. So you'd have to use the Expressive IDF library in order to get access to those, and they come as callbacks. So because of that, there's very little functional difference between indicate and notify. So if you're wondering why not use indicate, well, there's a good reason. It's extra overhead, which functionally gains you nothing. Well, there's extra overhead to our writes too. And for turning an LED on and off really probably doesn't matter. but we're going to try this. We're going to do some experiments with that. And more specifically, we'll do experiments with moving the motor. We're going to try it with both using write and with write and R. Okay, so first we'll just change this to write. We'll come over here and we'll build, we'll update our ESP32. You notice we've got our debugger going in JavaScript. We got our app, our handy little app here. We can take out our pen. All right, so we run a little test here when we start up. All right, that's all done. So now we can connect. All right, so now we're connected. You know, we were communicating just fine. Our red LED comes on. Notice we can use our mouse to do the same thing. Now, move motors. Notice we get these warnings. We got 9 of these warnings. And these warnings are coming from here. So when we move the servo motor, we're getting warnings. Now, what happens if we write using an R? So now, when the client writes to the ESP32 is not going to respond, not going to verify that that came through correctly. Do things work better? Let's find out. We'll update our ESP32 and we'll try this again. Notice we've written the code so that when the ESP32 disconnects because it's getting its code updated, our JavaScript does a page reload. So it's all ready for a new connection. That's a very handy thing to do. Keeps things working smoothly. All right, so now we can do this again. And since you know what I'm doing, I'm probably going to start using my finger. All right, so again, no problem. And no warnings. All right, but does that mean we're still okay? Because if I send a bunch of moves, and now I'm not insisting on a reply, are all those moves getting through? And the answer is yes, they are. So I'm having the ESP32 tell me how many moves it made when it sends the status update. It says, okay, stopped 93. I made 93 moves. And then I'm having the JavaScript tell me how many moves it sent. 93 moves. So we're getting all of our moves. Everything's working properly. By getting rid of that reply, which we don't have the hooks to anyway, we now have a more robust way of communicating. So that's very important to know. And a very simple conclusion to that is don't use write. Use write and R. 2 reasons. Number one, write, the reply that's required with write has limited utility when you're using the Arduino library for BLE. So don't bother with a reply of limited utility. And then number 2 is when you do use it, it tends to fail. And for reasons that probably have to do a little bit with timing and probably a lot to do with WebBLE. If you're writing your own app, you may find some utility in this. But if you're using WebBLE like we are, it's clearly a bad idea to use write. And you want to use write-NR. The last thing we looked at is whether or not we should offload the moving of the motors when the client tells us to move motors. And when that happens, BLE will call this method. The client says, move the motors. This method gets called by the BLE layer that we wrote. And we could do anything we want here. In this case, we're going to move these motors. Now I've set this up so that we can offload that movement to another thread using the built-in real-time operating system that comes with ESP32s, or not. And if we don't, then this code isn't going to complete until we've sent all our commands to the motors. Whereas here in this code, we just have to pop those commands on a queue and then we're out of here. So this is going to be less time. So we're not holding up anything going on with BLE, and this will be more time where we might be holding up what's going on with BLE. So we wanted to try this both ways. And so right now, this is false, and we've seen that working when it's when we're not using the queue, and then we can change this to true. And now we're going to queue those things up, put that, bake that into the ESP32, and then we'll make sure everything still works. So already we haven't really had BLE problems when we're waiting for all this to occur. So we probably don't need to do this, but it's a darn good idea to offload anything that's time consuming in these callbacks. So we already know it's not necessary. The question is, does it work? And if it works, it's a good idea, so maybe we should stick with it. All right, so here's our acid test. And everything was working just fine. 41 moves. Yep, everything's working just fine. No errors, no warnings. 65 moves, 65 moves. It's lovely. So we'll probably stick with using the queue, even though we don't have to. Okay, what did we learn today? We learned that touch events from our phones sent over WebBLE are fast and furious. So we learned we need to restrict the number of commands we send to our projects if we're using a touch interface. Then we also learned something about CCCDs, and that really we don't need to bother with them at all if we don't want to, unless we're using the notify characteristic. If we're just using read and write, we don't need them at all. And if we're using indicate, we should probably rethink that. We also learned about min preference and what that really is, that it's an interval with which the client and server will communicate, and that for WebBLE, it doesn't matter what you set it to. So you need to set it, but you don't need to set it to anything in particular. Use 0. We learned about the difference between a write characteristic and a write-NR characteristic. The write-NR is what we always want to use. Write is to creating overhead and creating potential for errors. We looked at offloading our motor movements when we're getting BLE commands. And we know with the ESP32s, we get a real-time operating system, so we can create a thread with which to use to move that motors. That's a great idea. We didn't have to for our demonstration experiment, but we did anyway. I hope you enjoyed this video. I have to say, it took me way longer to create it than I thought it would, but as always, I enjoy doing these. I get no benefit directly, indirectly, just the joy of doing it. And thanks for watching.